Let's Godot, a series where I recreate video game mechanics in the Godot game engine. So even though I've never really been that into sports games, one of them I did play a bit growing up was the Mario Golf series. Something about the relaxed nature of it all and how the skill is based on button timing just worked for me. And I also liked how it rewards you for developing an intuition for how the physics works. So I figured I'd give it a go myself. Now you'd think I'd start with a ball or a player scene, but no. In this case, for whatever reason, I decided to start by making a UI element. In particular, I started by making that little gauge that appears at the bottom of the screen as you make your shot. To do that, I decided that the progress bar node would be the easiest way to accomplish things. The gauge would always be in one of 4 states: idle, power, accuracy, and finish. When in idle, it waits for a mouse click. But when in power, it builds up toward the max and goes back and forth endlessly until an input is made. So the goal is to click when the bar is at max power, and then it will give you a short window to make sure your shot is as accurate as possible. In the original, this was actually accomplished with another button press, but I figured it would be interesting to spice things up in my own way, which I'll get to later. The next thing I did was add a little ticker box at the end of the gauge, just for some visual appeal. The way that's accomplished is by moving its position whenever the gauge value changes. I had to mess around a little bit to get this to work right when scaling the window and whatnot, but eventually I got it working as intended. Part of me does feel like it would have been easier to render all of this gauge stuff as sprites instead of UI elements. I've always found that doing anything more involved with those can get finicky pretty quickly, but it works. Anyway, after that, I worked on the ability to stop the gauge at a certain value so you can decide how much power to give your shots, as you're currently seeing here. Then, it was finally time to add a way to determine accuracy. So what I came up with was a ball that appears at a random spot on the screen above the gauge. Your goal, then, is to move the reticle to the center of the ball for a perfect shot, or to the sides if you want your shot to go at a bit of an angle. I think this is an interesting gameplay idea, although it does seem a little bit clunky. What do you think? After making that, I decided it was time to model an actual course, although I did redo this later on. I learned pretty quickly that my ability to model larger, more realistic things was a bit lacking, so I kind of struggled through it. But if I ever decided to make a whole game out of this, you can bet I'd eventually figure out a more streamlined approach to designing levels. In any case, after that, I whipped up a quick golf ball scene and threw a texture onto it, which is what you're seeing now. It's nothing fancy, but I'd say it gets the job done. And now, finally, we can actually write some code to hit a golf ball and have it go somewhere. Since I already had the power gauge working, all I had to do was hook that up to some logic that applies an impulse to the ball to make the shot, and I'd say that works pretty well. But one thing I realized quickly was that I needed a way to selectively tweak the physics for the ball for the sake of gameplay. It would be really boring to have to watch the ball slowly roll down a hill, for example, so I eventually added some logic to gradually increase the angular damping when in contact with the ground for too long, making it stop much faster. Of course, the fun of a golf simulator is in seeing where your shot should go with perfect play, so the next thing I needed to figure out was how to display the arc your shot would take. Making that was a little bit more complicated, but the way it works is basically by doing a crude physics simulation, rather than having the engine do things itself. Basically, you've got a starting point and a starting velocity, so as long as you take into account gravity and drag, it's possible to accurately predict how the ball should move through the air. And knowing that, I was able to draw the arc. After getting that working, I needed something easier to add, so I grabbed this GoBot model from GD Quest, link in the description. It doesn't do much of course, but just having it there is nice for motivation, I think. So at this point, the accuracy widget wasn't really doing anything. So I hooked up some simple logic to alter the path the ball takes based on how far away from the center you are when the gauge goes back to 0. I also added some logic to show the apex and landing spots for the arc, as I felt like those would be useful to have for various other things later on, like for getting camera angles and whatnot. Shout out to the Marker 3D node, by the way. I don't see them used much, but I like them because they're just explicitly about marking a point in space, and also because that shows a little symbol in the editor. Anyway, the result of the arc markers are demonstrated here. As you can see, with a perfect shot, it goes straight through the apex and lands directly onto the target. So yeah, it was nice to get confirmation that things were being properly predicted. But the fun of this kind of game is not to have perfect information after all. So the next thing I added was a grid that shows where your ball should land. To do that, I just used a grid texture on a decal 3D node that gets placed at the predicted landing spot using one of the markers I just mentioned. It's nice because when you're lining up your shot, it's a good way to see the slope of where you're landing so you can predict where the ball might roll once it does. I initially thought I might have to do a bunch of raycasts or something to construct this grid, but it turns out the decal node once again comes to the rescue. At this point though, I was already kind of getting tired of the course that I made, so I modeled a new one. I struggled even more with this one though, and should have probably just used a single flat plane and sculpted it, but it worked for the purposes of having something nicer to look at. I then painted a quick and dirty tree texture and set them up as billboarded objects in the level. Of course it would have been just as easy to make actual 3D trees, but I kind of wanted to go for the nostalgia factor here. Next up was just some simple logic for moving the camera around, so you can zoom into the target area and back to the ball before making your shot. To keep it smooth, I also used a lerp in a camera target variable, so it wouldn't be so jarring moving from spot to spot. At this point, there wasn't really too much more that needed to be added, but one thing that was definitely needed was wind. To accomplish that, I added two variables to the level scene, wind angle and wind magnitude. Whenever those values change, a signal gets fired that those values are now updated. Then, in the golf ball script, I have a function that gets called whenever the wind changes, and it updates a wind force variable in that script. Then, if the ball is in the right state, it sets the constant force variable to the wind force. The reason for this is so the wind only applies when the ball is in the air. After getting the wind working, I added a nicer way to show that by modeling this little arrow in Blender and then putting that into a sub-viewport in the top right corner of the screen. And the nice thing about this is that I can just copy the rotation for the actual camera in the level, and then apply it to the camera in that viewport. And the result is the arrow pointing in the direction of the wind, no matter how the camera happens to be rotating in the actual level. Which is nice and intuitive, I think. After that, the only thing left to do was to add different clubs and the ability to putt. To do that, I added another variable which determines which club you're using. Higher values give you more range, and on the lowest value it putts horizontally instead of up into the air. Overall, this was an interesting one to tackle, as it required putting together a handful of very different components to get a full gameplay experience. Without any one of those though, the whole thing wouldn't really work. Which I think is the cool thing about prototype projects like this. It's all just about making what they call a vertical slice and seeing if that feels fun to play. If you can make something fun without any extra bells and whistles or polish and whatnot, it can only get more fun from there. Let me know what other game mechanics you'd like to see made in Godot. Thanks for watching!